Okay, so we're looking at this one. I would say again, try and identify the like terms.
2y, 3y, and 3y.
Yep. So at 2y, 3y, 3y. Okay. So the way this is structured, I'm not sure we can do that. I think the way they're trying for us to look at doing this is to say, let's take that. Yeah. Then let's take all of that, and then let's take that. Okay. So if we were to look at that, we would say 7 multiplied by 2 is 14, and x times y is that. Now it's -1, isn't it? Times 3 would be -3. You alright with that? Yep. X squared times y would be 3x squared y. And then what would this be? So, okay, so we've got the sign of a negative and a positive. So what's the answer going to be? What's a negative multiplied by a positive? Yeah, you guessed there, I think, judging by the inflection in your voice, but you should have it in your glossary. All right. So we've done the signs. What's the next job to do? The numbers. What are they? So what does that become? Yes. And x and y. Yeah? We could have left that as 3 times 3, but we can simplify that, but we can't simplify x times y. Okay? So we've got 14xy, take 9xy, leaves us with
5xy.
good. Take 3x squared y. Probably need to leave it at that because there's nothing that's not like to that because of this squaring. It doesn't have a square there, so we'd need to leave it like that. Is that okay? Yeah. So have a looking at the question. When we identify what the like terms are, we can see that it's that and that and that, but they're on the other side of a multiply sign, so I think that what they're driving at is to do it section by section. Okay? Try B on your own and see how it is you go, alright? So it says, really importantly, I think it says where possible simplify. Okay? You can't always simplify. But I think we spoke about the fact that if you're adding or subtracting like terms, think of them as objects in your life. So where 6x takes 6x, think of it as 6 oranges, for example. So I've got 6 oranges, someone's taking 6 oranges away. I'm not going to be left with 0 oranges, I'm just going to be, or I'll be left with 0. Okay? So when we're adding and subtracting like terms, think of them, I guess, as objects, which may, for those of you that are struggling with the concept, it may help you understand it a little better. So as we go along, what's the thing to remember with this here, Jeremy?
There's a 1 for the x.
There's a 1 before the x, okay? And Beth, are you in one day? Sorry, you'll pass that. Sorry. Cheyenne, sorry. What's the negative belongs to which? The 6x or the 1x? It belongs to the 1x, okay? So it's 6x, take 1x, leaves us with just 5x. That's okay. when we go through here. The other thing to be mindful of is that P times Q or Q times P mean the same thing. Okay, this might be a rehash. We're going to go into a bit more difficult ones in a minute. But if P equaled 2 and Q equaled 3, here we would have 2 times 3. And 2 times 3 we know is 6. Here we would have 3 times the 2. It would still give us 6. Alright, so the important thing to remember with this is that PQ is the same as QP. It can be seen as the same. When we get up to trickier ones where there's more than one, alright, we've just got to identify what our like terms are here. So what are our like terms here, Nikita? They're our like terms. So in total, what are our like terms there? 7b squared plus 2b squared. Okay? And I've just said to Holsty that the important thing is about doing all the steps rather than just come up with the answer. Okay? Because if you get the answer wrong, I can at least give you some marks for getting this right. Notice that the -6 comes down because we can't do anything with that. And we just shuffle these across to be alongside each other. 7b squared plus 2b squared. That will leave us with 9b squared take 6. Hopefully you can identify that. Alright. Let's try, Garrett, let's try R, one of the most difficult ones in this set. Remember that they get more difficult as we go down. So identify some of the like terms here for me, Garrett, please.
Negative 8x and negative 3x.
Excellent. Negative 8x and negative 3x. Good. Are there any other like terms there, Ash? Are there any other like terms there? We've just circled those two. Sorry? Yep. So this is the same as this. Okay, so 3x squared and negative x squared are the same. So we can do something with them. What I'll encourage you to do is put the ones in the squares together and the one in the circles together. So let's go 3x squared. I don't make anything up here. Take x squared. And negative 8x. Take 3x. Okay, now that they're together, maybe that might help you. It may help you to identify the fact that they're all together. 3x squared, take x squared. What does that make us end up with, Kayla, please? 2x squared, good. 3 oranges, take 1 orange, is 2x squared. And then we've got negative 8x, take 3x. Remember our number lines. Okay. Negative 4, negative 5, negative 6, negative 7, negative 8. Okay, negative 8x, take 3x. We are starting at negative 8. So we're starting there. Which way am I going to go, Taylor? Because I'm taking 3 or subtracting 3. Am I going to go to my left? We're going to go to the left, or am I going to go to the right? To the left or to the right? To the right. So if I'm taking 3, let's do the number line like this: 0, 1, 2, 3, 4. If I said 4 take 2, I'd be starting at 4, and when I take 2, would I be going to the left or would I be going to the right? To the left. Every time I take, I go to the left. Every time I add, I go to the right. So put in positive numbers. Sometimes that helps to work that whole number line system out. So negative 8, take 3. I'm going to the left. Negative 8, I'm going to take 3. What's that number there, Ash? Negative 11. Good. negative 11 x. Can I simplify that at all, Connor? I can't from there, can I? Identify one that you need me to go through because you just need a bit of reinforcement. Anyone need me to go through any of those others? Yes, Nikita? D. This one here. Yep. So that relates back to my PQ conversation up here. Okay. Are these like terms, therefore, do you think? They are like terms. C times D is the same as D times C. How many CDs or DCs do I have? I've got 2 here. How many have I got here? And what am I doing to them? I'm plussing them together. So how many have I got in total? 3. And let's work with the alphabetical order system. Let's go 3CD. Okay? Just a tricky one to test all your knowledge about algebra, I suppose. The fact that you go in alphabetical order, the fact that CD is the same as DC. Just testing all of that knowledge in your head, I suppose. And Jeremy, we'll just go with one down here. Let's go with B. Can you, the first step, what's our first step?
Identifying the like terms.
Awesome language. Identify our like terms. What are our like terms here, Sean? Well, if you're going to sit here and watch, make sure you concentrate. All right, otherwise you're better off getting on with your learning. Jeremy, what's some like terms here?
M squared,
Yes.
2m squared.
Good. M squared and 2m squared. And Ash, what's some other like terms there? So have a look up here. Is there any other like terms that you can identify there? Jack?
Negative 4 and negative 4 and positive 3.
Good. Negative 4 and the positive 3. Okay. What's my next step? Well, my next step is to put them all together. So put my rectangle together. M squared plus 2m squared. And put my circles together. All of this in my circle is negative 4 plus 3. M squared plus 2m squared gives me what, Nikita? Gives me 3m squared. And negative 4 plus 3. Negative 4 plus 3. Negative 1, I'm going that way, is negative 1 equals 3m squared, take 1. Okay? So keep going through that process, identify your like terms, then put them together, and then try and add or subtract them.